For decades, warp drive has felt like pure science fiction, right? A cool idea for crossing the insane distances between stars. But what if I told you it's slowly but surely moving out of fiction and into the very real world of theoretical physics? Yeah. Today, we're diving into the actual science that might, just might, make it a reality one day.
You've seen images just like this 1,000 times. They get you dreaming about a future where humanity isn't just stuck in one solar system. For the longest time, though, the math just didn't work without basically invoking magic. But that's changing. Scientists are realizing the key isn't a more powerful engine. No, it's about learning how to manipulate the very fabric of space-time itself.
And that's it right there. The secret to a real-world warp drive isn't about blasting through space. It's about bending and warping the universe around your ship, creating a little bubble that can kind of ride a wave of space-time to its destination.
Okay, so to really get where we're going, we first need to make sure we're all on the same page about the original idea.
Now, this is the most important part to get your head around. The ship inside this warp bubble, it isn't actually moving at all. It's just sitting there, totally stationary, never breaking that cosmic speed limit, the speed of light. It's the space around it that's doing all the work.
This is the perfect analogy. Seriously, you're not running, you're not even walking, you're just standing there, and the floor itself is pulling you along. With a warp drive, your ship is the passenger, and space-time is that moving sidewalk, carrying you wherever you want to go.
So back in 1994, this whole idea took a massive leap from just an idea to actual mathematics. But it came with one giant, seemingly impossible catch.
So this physicist, Miguel Alcubierre, he showed that Einstein's own equations for general relativity actually allowed for a warp bubble to exist. I mean, that was a huge revelation. The only problem? To bend spacetime in just the right way, you needed something with anti-gravity, some kind of substance with negative mass or negative energy.
And this chart lays out the problem perfectly. Everything we've ever seen, all the matter and energy in the universe, is positive. It has mass, it creates gravity, it pushes out. But the theory required its total opposite, negative energy. This theoretical, exotic stuff that would pull inward, creating anti-gravity. And we have never, ever seen it. So for decades, that made the warp drive a cool math trick, but a physical impossibility.
But, physicists are a stubborn bunch, and just recently, they figured out some ways to kind of hack the original warp equation with models that might not need that exotic stuff at all.
These breakthroughs are coming from a couple of new angles. First, by using something called a soliton. Now, the best way to think of a soliton is like a perfect, stable wave. It can travel for huge distances without ever losing its shape. It's like a single ripple in a pond that just never fades away. The new idea is to build a warp bubble out of one of these super stable waves.
And this was a total game changer. A physicist named Eric Lentz came up with a model for a warp bubble that's built from these solitons. And his math showed that, in theory, it could be powered by things we actually understand, like just immense amounts of normal energy and superheated plasma. No exotic matter needed.
And here it is. This is the crucial bit. Lentz's model showed that the energy you'd need to create this warp bubble was entirely positive. For the first time ever, we had a mathematical model for faster-than-light travel that didn't have to rely on physically impossible negative energy.
His model also gave us a picture of what this warp field would look like. See that flat bit in the middle? That's the stable bubble where the spacecraft would just sit, totally protected from any crazy forces. All the intense bending of spacetime happens on the outside edges, keeping the ship and its crew completely safe.
So, building on that amazing momentum, the absolute latest research is taking it even further, evolving the very structure of the warp field itself.
This new research from physicist Harold Sonny White takes another huge conceptual leap. It basically asks, does the warp field have to be this single, all-encompassing shell? Or what if it could be more, modular? Just look at the difference here. On the left, that's the classic Alcubierre model, one big bubble. But on the right, that's the new idea. It suggests you can get the exact same effect by creating a bunch of smaller, separate regions of distorted spacetime. So why is that such a big deal? Well, because it proves a really fundamental point. There isn't just one right way to build a warp field. Spacetime isn't some rigid sheet. It's a flexible fabric, and it turns out we can shape and manipulate it in way more complex ways than we ever thought possible. All of this incredible work is pulling warp drive theory out of the fringes and turning it into a serious, collaborative field of science. This is real now.
This quote from Gianni Martire, he's the CEO of the think tank Applied Physics, he just nails it. It perfectly captures this moment we're in. That gap between what we can dream up and what physics actually allows, well, it's getting smaller.
And they're building the tools to back it up. Applied Physics has developed something called Warp Factory, and it's basically a virtual wind tunnel for spacetime. It's this powerful simulator that lets physicists create, test, and tweak different warp designs with just a few clicks.
And to really get things moving, they are putting their money where their mouth is. Applied Physics is offering $500,000 in grants to get new physicists and engineers working on this problem. This is how a cool theory turns into a real scientific mission.
So all of this points to this huge shift in thinking. For decades, the big question was, does physics even allow this to happen? The latest research is starting to suggest that the answer is, yeah, maybe. So now the question is becoming, what would it take to actually engineer this thing?
Now look, we are still a very, very long way from booking a trip to another star system. But these breakthroughs have completely reframed the challenge. The path to the stars might not be blocked by the laws of physics anymore. Instead, it might just be waiting for a generation of engineers who are brilliant enough to build it. And you know what? That changes everything.